Hello guys. In last lecture, we had a discussion on network software, protocol hierarchies, and design issues of the layers. Today we will discuss on the OSI reference model. This model is based on proposal developed by the International Standards Organization ISO. The model is called as ISO OSI Reference Model. OSI stands for Open Systems Interconnection. It deals with connecting open systems. That means systems that are open for communication with other systems. The OSI model has 7 layers: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. The processes in the application layer generates the data at the transmitter side. Then data moves to the presentation layer, session layer, transport layer, network layer, data link layer, and via physical layer, data goes from source machine to the destination machine. In destination machine, its physical layer receives the data and forwards that data to the data link layer, then network layer, then to the transport layer, session layer, presentation layer, and application process in the application layer receives the information. There are some principles used for designing the 7 layers of OSI reference model. These design issues assumes a layer should be created where a different abstraction is needed. Each layer should perform the well-defined function. The function of each layer should be chosen with an eye towards defining internationally standardized protocols. The layer boundary should be chosen to minimize the information flow across the interfaces. The number of layers should be large enough so that necessary functions are not thrown out of the layers, and small enough that the architecture does not become unwieldy. The bottommost layer is the physical layer. The physical layer coordinates the functions required to carry a bit stream over a physical medium. It deals with the mechanical and electrical specifications of the interface and transmission medium. It also defines the procedures and functions that physical devices and interfaces have to perform for transmission to occur. The physical layer is also concerned with physical characteristics of interfaces and medium. The physical layer defines the characteristics of the interface between the devices and the transmission medium. It also defines the type of transmission medium. Then the representation of bits. The physical layer data consists of stream of bits, that is the sequence of logical zeros and logical ones. In order to transmit bits, bit must be encoded into signals that may be electrical or optical signals. The physical layer defines the type of encoding, that is how zeros and ones are changed to signals. Then physical layer also deals with data rate and baud rate. Data rate is nothing but the number of bits transmitted per second, and baud rate is nothing but the number of signal alterations per second. Baud rate may be equal to or greater than bit rate. Then physical layer defines the duration of bit. Next responsibility is synchronization of bits. The sender and receiver not only must use the same bit rate but also must be synchronized at the bit level. In other words, the sender and receiver clocks must be synchronized. The physical layer is concerned with the connection of devices to the media. In point-to-point configuration, two devices are connected through the dedicated link. In the multi-point configuration, a link is shared among several devices. The physical topology defines how devices are connected to make a network. This is also responsibility of the physical layer. Devices can be connected by using a mesh topology, that is, every device is connected to every other device, or a star topology, in which the devices are connected through the central device, or ring topology, in which the device is connected to the next forming a ring, or bus topology, in which the every device is on the common link, or a hybrid topology, in which the or this topology is a combination of two or more topologies. Then physical layer also defines the direction of transmission between two devices, simplex, half duplex, or full duplex. In simplex mode, only one device can send, the other can only receive. The simplest mode is a one-way communication. In half duplex mode, two devices can send and receive, but not at the same time. In full duplex mode, two devices can send and receive at the same time. The next layer is the data link layer. The responsibilities of the data link layer includes first one, the framing. Data link layer receives the packets from network layer and converts the packets into frames. The next responsibility is the physical addressing. If frames are to be distributed to different systems on the network, the data link layer adds a header to the frame to define the sender and receiver of the frame. If the frame is intended of a system outside the sender's network, the receiver address is the address of the device that connects the network to the next one. Then flow control mechanism. If the rate at which the data are absorbed by the receiver is less than the rate at which the data are produced in the sender, then the data link layer imposes a flow control mechanism. Next function is error control. The data link layer adds reliability to the physical layer by adding mechanisms to detect and retransmit damaged or lost frames. It also uses mechanism to recognize duplicate frames. Error control is normally achieved through a trailer added to the end of the frame. Next functionality of data link layer is access control. When two or more devices are connected to the same link, then data link layer protocols are necessary to determine which device has a control over the link at a given time. This access control functionality is handled by separate sub layer in the main data link layer, is called as medium access control layer. Then next layer is the network layer. The network layer is responsible for the source to destination delivery of packets, possibly across the multiple networks. Whereas the data link layer controls the delivery of packets between two systems on the same link. The network layer ensures that each packet gets from its point of origin to its final destination. If two systems are connected to the same link, there is no need of network layer. But if two systems are attached to the different networks, then there is a need of network layer. The main responsibility of the network layer is the logical addressing. The physical addressing implemented by the data link layer handles the addressing problem locally. If a packet passes the network boundary, we need another addressing system. The network layer adds a header to the packet coming from the upper layer that includes the logical address of the sender and receiver. The next function of the data link, next function of the network layer is routing. When independent networks or links are connected to create a large network, the connecting devices, which may be routers or switches, route or switch the packets to the final destination. One of the functions of the network layer is to provide this mechanism. Apart from these responsibilities, one more important responsibility of network layer is the congestion control. If congestion happens within the network, there is a possibility of loss of information. Congestion means crowd of information. Network layer supports multiple or many congestion control mechanisms. Then another function supported by the network layer is accounting of the information. It keeps the account of how much amount of information is uploaded by the user, how much amount of user is downloaded by the user, and it generates the billing information depending upon tariff plan of the user. The next layer is the transport layer. The transport layer is responsible for process to process delivery of the entire message. The process in an application program running on a host. The process is application program running on a host. Whereas the network layer oversees source to destination delivery of individual packets. It does not recognize any relationship between those packets. It treats each one independently. The transport layer, on the other hand, ensures that the whole message arrives intact and in order. It applies both error control and flow control at the source to destination level. That is over the end to end link. Other responsibilities of the transport layer includes service point addressing. Computers often run several programs at the same time. For this reason, source to destination delivery means delivery not only from one computer to the next, but also from specific process that is the running program on one computer to the specific process that is the running program on the another computer. The transport layer header must therefore include a type of address called a service point address, that is the port address. The network layer gets each packet to the correct computer. The transport layer gets the entire message to the correct process on the computer. Next function of the transport layer is segmentation and reassembly. A message is divided into transmittable segments. Each segment contains the sequence number. These numbers enable the transport layer, or these numbers enable the transport layer to reassemble the message correctly upon arriving at the destination and to identify and replace packets that were lost in transmission. Next function is connection control. The transport layer can be either connectionless or connection oriented, but in OSI reference model, transport layer is connection oriented. The connection oriented transport layer makes a connection with the transport layer of the destination before delivery of the packets. Once the connection is established, packets were delivered. After all the packets are transferred, then lastly, connection is terminated. Then flow control mechanism. Like the data link layer, transport layer is responsible for flow control. However, flow control at this layer is performed end to end rather than across a single link. Then error control. Error control, like the data link layer, the transport layer is responsible for error control. However, error control at this layer is performed process to process rather than across a single link. Sending transport layer makes sure that the entire message arrives at the receiving transport layer without errors. Error correction is usually achieved through retransmission. The next layer is the session layer. The services provided by the first three layers, that is the physical layer, data link layer, and network layer, are not sufficient for some processes. The session layer is the network dialog controller. It establishes, maintains, and synchronizes the interaction among communicating systems. The specific responsibilities are dialog control, synchronization, If dialogue control is considered, the session layer allows two systems to enter into dialogue. It allows the communication between two processes to take place in either half duplex mode or full duplex mode. As far as synchronization is considered, the session layer allows the process to add checkpoints or synchronization points to a stream of data. For example, a system is sending a file up to 1000 pages. Then it is advisable to insert checkpoints after every 100 pages to ensure that each 100 page unit is received and acknowledged independently. In this case, suppose crash happens during the transmission of page number 523. Then it is necessary, in this case, it is necessary to retransmit only pages from 501 to 522 by 23. Pages previous to 501 need not to be retransmitted. Then next layer is presentation layer. The presentation layer is concerned with the syntax and semantics of the information exchanged between two systems. The responsibilities of the presentation layer includes translation, encryption, and compression of the data. First, we will see translation. The processes, that is the running programs in two systems, are usually exchanging information in the form of character strings, numbers, and so on. The information must be changed to bit streams before being transmitted. Different computers use different encoding systems. The presentation layer is responsible for transmitting or converting different encoding methods. The presentation layer at the sender changes the information from its sender dependent format into a common format. The presentation layer at the receiving machine changes the common format into a receiver dependent format. Then encryption. To carry sensitive information, the system must be able to ensure privacy or security. Encryption means that the sender transforms the original information to another form and sends the resulting message out over the network. Decryption performs reverse task and transforms the message back to its original form. The next is the compression. Data compression reduces the number of bits contained in the information. Data compression performs particularly data compression is important in the transmission of multimedia information such as text, audio, and video. When compression is applied over the data, number of bits representing information goes on reducing. So, speed of communication increases. Along with increase in the speed, there is a reduction in the storage space requirement. Then final layer is the application layer. The application layer enables the user, whether human or software, to access the network. It provides the user interfaces and supports for services such as electronic mail, file transfer, etc. Some of the services provided by the application layer includes network virtual terminal. A network virtual terminal is a software version of a physical terminal, and it allows a user to log on to the remote host. To do so, the application creates a software emulation of a terminal at the remote host. The user's computer talks to the software terminal, which in turn talks to the host, and vice versa. The remote host believes it is communicating with one of its own terminal and allows the user to log on. Next example is file transfer, access, and management. The application allows a user to access files in a remote host. It also allows to retrieve files from the remote computer for use in the local computer. And also, it allows to manage or control files in a remote computer locally. Transport layer also supports mail services. This application provides the basis for email forwarding and storage. Then directory services. This application provides distributed database sources and access for global information about various objects and services. If summary of applications is considered, which is shown in this figure, here the physical layer is responsible for transmission of bits over a medium to provide mechanical and electrical specifications. Data link layer is for organization of bits into frames and to provide the hope-to-hope delivery. Network layer is for moving the packets from source to destination and to provide inter-networking functions. Routing of the information, congestion control, as well as accounting of the information. Transport layer is for providing the reliable process to process message delivery and error recovery mechanism, flow control mechanisms, segmentation and reassembly, along with multiplexing and demultiplexing functionalities are also incorporated in the transport layer, are supported by the transport layer. Session layer is used to establish, manage, and terminate the sessions. It mainly responsible for dialogue control and introducing the checkpoints in the communication of large files. Presentation layer translates the information coming from applications into standard formats. It deals with the encryption and decryption of information. It also deals with the compression and decompression of the data. Then final layer is the application layer. It allows the access to the network resources. This is about OSI reference model. In next lecture, we'll discuss TCP/IP reference model. Thank you.